to touch on a few things before we get started. The first thing is the structure of the notes are going to be a little bit different. I've retyped them up, tried to take out anything that I knew for sure we weren't going to need, and then I also, instead of labeling them by sections, since we're not really using the textbook, I just put the standard. The standard, if you can meet this standard that's in bold, I can solve the polynomial equation using synthetic division when I'm given one of the zeros. Then you'll get a 3. Because that means you're proficient. To get a 4, you have to show me you can do a little bit more than just the standard, which we will practice still, but if you meet this, you get a 3. The extension to that is you can solve a polynomial equation using synthetic division when you're not given the 0 to start with, and you can apply this method in a real-life scenario to find a solution. So, with both of these, so if you can show me this stuff, then you'll get a 4. And when we take the test, on the test you'll see, they're tiered questions. They're not going to look the same like what you have in science. But there'll be a question where if you get that question, it'll show me you have a basic understanding, so a 2. You'll have a question that you'll be able to earn a 3 on if you get it. And then if you can extend it, there'll be another question where you can show me whether or not you know how to do this. And to get a 4, you'd have to be able to do the basic, the 3 question, and the 4 question. So, just to let you know what that looks like. Alright, you learned about synthetic division and how we can use it to divide polynomials. We can use it to divide polynomials when the divisor is in the form, oh dear, now my pen's not going to work. Oh, there we go. Oh, there we go. X minus c, or sometimes it's written in this form, where we would really see it as x plus c. We're going to use this method now to help us break down a larger polynomial into what we call depressed polynomials. Now, that isn't because the polynomial is sad or needs counseling. It's because the depressed means, like, if something is depressed, like you can think of it, maybe just looking at the word pressed, it's pressed down. A depressed polynomial is a polynomial that's hidden within the bigger polynomial. So we use it to break it down. So we start maybe with a cubic, and then we use the answer to break it down to a quadratic. The quadratic would be called a depressed polynomial because the quadratic was hidden within the bigger polynomial. Basically, we're going to do that until we can solve for all the zeros using factoring or the quadratic formula, which we can only use with quadratics, remember. This is another method at our disposal besides just factoring patterns that we can use to solve polynomials. Okay. Now, this is kind of called the remainder theorem, but really what we're focused on today with it is the factor theorem. The factor theorem states that some value k is a 0 of p of x if and only if p of k equals 0. So, that's the general form, or the general statement. I'm grabbing this book here for a second. So basically what that's saying is, whatever your c, and maybe we should use a c here. Yeah, let's use c since we use c up here. It's just a variable to represent an x value. Let's adjust that to a c. So we can say that c is a 0 of p of x if and only if p of c equals 0. Meaning, if you can plug in c and get 0, then c is an x-intercept. That's another way to look at it. Now, we've used synthetic division to actually divide polynomials, but what you didn't know is you could also use synthetic division you can also use synthetic division to plug in values. And maybe we'll do that really quick. I'm just going to do a quick little problem. Like if I wanted you to plug in 3 to to function. And the function was, I don't know, 2x cubed minus 3x plus 1. Okay? I'm going to plug in 3. Now notice I'm not dividing, so I didn't switch the sign here, but I'm just going to plug in 3. So we have 2, 0, negative 3, 1. I'm going to go through this really quick. 2, 6, 6, 18, 15, 45, 46. This number that you get in the remainder spot, if you're not dividing and you're just using this process to plug in a number, this number would be what you get if you actually plugged 3 in. So let's show you how that happens. Sorry, I didn't have all my little tools here. So if I was to plug in 3, I'm going to store 3 as my x. And then we have 2x cubed minus 3x plus 1, 46. So you can see that my remainder is what I would get if I plug 3 into the function like we do normally. What's nice about this is really quick to do if you don't have a calculator. You can plug 3 in fairly quick, and you get that f of 3 equals 46. So we're going to be doing a similar process here, except the number that we plug in, we've already been told that it's going to be a 0. So my answer here should be a 0, which means what's left over is my depressed polynomial. So let's look and see how that happens. For example 1, let me get a good example here. Hold on just a moment. Here we go. Okay. So the function that we're going to look at for example 1 is x cubed plus 11x squared minus 150x minus 1512. And we're told that f of negative 14 equals 0. So what this is telling you here is that if I plug in negative 14, I should get a y value of 0. So we're going to actually test this theory, and we're going to plug in negative 14 to this using the synthetic division process. So we have 1, 11, negative 150, negative 1512. Bring down the 1, negative 14. We have negative 3. If you add them, 14 times 3 gives me 42, which gives me negative, I want to make sure I do that right. Yep, negative 108, and negative 108 times negative 14 gives me positive 1512. So when I add my last column, my remainder ends up being 0, which it should be because I was told that if I plug in negative 14, I get a remainder of 0. What's left over here is my depressed polynomial, so I'm actually going to write that. We have x squared minus 3x minus 108. And the directions here would be to solve for all x-intercepts. Okay? This is one x-intercept, so we're going to circle that as an answer. But then to find my other 2, because I have 3, because this is a cubic, I'm either going to use the quadratic formula to solve this, or I'm going to see if I can factor. Let's see if we can factor. Are there 2 numbers that multiply to get 108 and add to get 3? Let's see here. Yeah, 12 and 9 actually. So this one we can factor. X times x gives me that x squared. 9 times 12 gives me 108. And then if I add them in the right way, meaning the 12 is negative and the 9 is positive, I get negative 3. Okay, so negative 12 times 9 gives me negative 108. When I add them, I get negative 3. So this is the factoring. And then when you factor to solve, now we're going to take each one of these factors, set them equal to 0, and solve. So my other 2 answers end up being 12 negative 9, and then I'm going to list that negative 14. So those are my three x-intercepts in this case. Alright, so let's put some steps to this process, steps to solving using synthetic division. First thing you're going to do is use the 0 you are given. Oh, hold on just a second. Sorry for that. Alright, so use the 0 you are given. And we'll say plug it in to the function using the synthetic division process. Keep in mind that you should get 0 as a remainder. And the second step would be to rewrite the depressed polynomial and solve either by using the quadratic formula or by factoring. Now there might be one that we do where we actually have to do this twice. We only had to do this once because we have a cubic, and so when we plugged in a 0, my depressed polynomial ended up being a quadratic, which then you can factor or solve using the quadratic formula. So let's say we started with a quartic. Well, if you start with a quartic, then when you break it down once, you get a cubic. So then usually you're given 2 x-intercepts, and you have to use the other one to break down the cubic, and then finally you get down to a quadratic. So the goal is to get down to a quadratic so you can solve using the quadratic formula, or by factoring the rest of the way. Alright, go ahead and flip. Okay. So solving using synthetic division when given a 0. Alright, so we are going to solve, or the directions would be to solve f of x equals 4x cubed plus 9x squared minus 52x plus 15 if f of negative 5 equals 0. Okay, so again, you're given a function, you're given one of the x-intercepts, and you're told to solve it the rest of the way. So we're going to take the x-intercept they gave me, and we're going to plug it in using the synthetic division process. And you're not missing any terms here, so it should go pretty quick. Bring down the 4. Negative 5 times 4 gives me negative 20. Add. Negative 5 times negative 11 gives me 55. Add. Negative 5 times 3 gives me negative 15. We should get 0 as a remainder there. Then I'm going to rewrite my depressed polynomial, which is 4x squared minus 11x plus 3. And then we're going to either solve by factoring or the quadratic formula. Now, you can factor this one, but let's say you didn't know you could, so maybe use the quadratic formula, just so that we practice one of both. I'm going to put this into the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So we get 11 squared minus 4 times 4 times 3 all over 2 times 4. Okay, so you get 121 right there, minus 4 times 4 times 3, which is, oh, maybe you can't factor, minus never mind. You can't. Good. So we did it the right way. So I get 73 over 8. And since 73 can't be broken down anymore, there's my two x-intercepts along with the one that they gave me. So we could plot these on the x-axis. It would just be, they would just be decimals. All right. Now, solving using synthetic division when you're not given a 0. We're going to set this one up, but then we'll probably start with that before we get to the notes here. So here we go. Write down solve x equals 5x cubed minus 27x squared minus 17x minus 6. By finding an x-intercept and then using the factor theorem. Okay. So this is where we will start tomorrow for